Happy Friday, everyone. Welcome back to our Planetarium live stream, and welcome to Fan Friday. I'm your host, Patrick Hess, the Planetarium Specialist at Union Station. And thanks for joining us for another one of our live streams. If you're tuning in for the first time, welcome. Fridays are when we answer all of your fan questions, so be sure to be thinking of all your astronomy and space-related questions and put those in the comment section so we can talk about those and answer those questions for you. And if you're joining us, once again, welcome back. A little update on, or a reminder about what our schedule is these days. We're streaming live on Mondays, Wednesdays, and Fridays at 6 p.m. Mondays is our live star tour, where I give you a What's Up tour of the week, showing you what you'll see this week. Wednesday is our deep dive live stream where I dive into a topic in astronomy. We've covered topics like the solar system, stellar evolution, probes and rovers. This week we did a special stream where I taught you all about how a telescope works, and we actually built a telescope live on stream. So if you have a telescope lying around that you would like to learn a little bit more about, be sure to check out that stream. You can watch recordings of all of our streams, all of our past streams on the Union Station and Planetarium Facebook page, so be sure to check those out. A couple little housekeeping reminders. Union Station is hosting an auction right now, and be sure to not miss your chance to bid on all those awesome things. We've got a couple Planetarium-specific packages, private VIP showings at the Planetarium, so be sure to head on over. You can find links to this on the Union Station Facebook page and the Planetarium Facebook page, where you can bid on those auction items, and don't forget that all those proceeds do support Union Station's mission, operations, volunteers, and staff, including our Science City and Planetarium staff, like myself. So be sure to bid on those items if you'd like to support Union Station and Science City and the Planetarium in another way. We are going to start out by a little bit more housekeeping, because we did have one question submitted on Wednesday that I did not have a chance to answer. And this question came from Tammy. Again, we were talking about telescopes and how telescopes work. And Tammy asked, can we see anything further than Saturn with the telescope? So I was talking about observing planets through telescopes, and telescopes are great tools to look at planets. And you can also see planets with the naked eye. And if you've been watching our, if you've been tuning into our Star Tour live streams, then you'll know that Venus has been a planet very prominent in our early evening sky. And then in the early morning, you can see Mars, Jupiter, and Saturn as well. Now, planets are interesting because we can't see all of them with the naked eye, at least. The only planets that are visible with the naked eye are Venus, Mars, Jupiter, and Saturn. Mercury can sometimes be visible with the naked eye, but only under really optimal conditions and only if you have pretty good eyesight. So it's sort of sometimes visible. But then Uranus and Neptune, the other two planets, are not visible with the naked eye. They are visible through a telescope, though. They'll just be a little difficult to find, and you will need a map to pinpoint where they are before you try to find them in your telescope. But there are a couple tools you can use to learn or to help you find objects in the sky. Now, for example, there are a couple great websites that will show you charts outlining the visibility of planets. This is a great tool right here. I believe this website is just called Visibility of the Planets. But this has a whole slew of charts dating back and forwards in time, and 2020 is our year. And this basically just very, very roughly shows you and tells you when you'll find planets or whether or not they're visible right now. So as you can see, we are in May 2020, and Venus is visible at dusk and in the early evening. But in June, we won't be able to see it because it will be setting before sunset. And not a little FYI, we did have a cameo from my pet bird Helen in our last stream, and she may choose to join this stream as well. So just a little warning for any of you who have any negative feelings about birds. There may be a bird joining our stream at any given moment, so just wanted to warn you all there. She may fly over and say hi. It was Friday. I figured I'd let her join if she felt like it, but we'll see if that happens. So back to our little chart about the planets. So again, that is showing us Venus and then Mars, Jupiter, and Saturn. You can see in the morning. And this will also tell you when to find the other planets like Uranus, Neptune, and Mercury. But again, those will be a little trickier to find, and you'll need to be able to pinpoint where they are. The easiest way is by finding a star chart. There are a lot of apps that will show you live views of the skies. And then you can find these planets and where they are relative to constellations that they're near. and that's usually the best way to find those planets. So hopefully that kind of answers Tammy's question about specifically about planets, if we can see things further than Saturn through telescopes. Now, of course, looking at many things like through the telescope, we can see much, much further than planets in our solar system. We can see nebulas that are hundreds of light years away, and we can even see galaxies that are millions of light years away. So we can see very, very far, and we can basically see as far as light has, taken time to reach us. So we can see pretty far through telescopes. But in terms of like solar system objects in the category of Saturn, Saturn is the farthest planet we can see with the naked eye, but you can see Uranus and Neptune through a telescope as well if you know where to find them. Let's go back over here. There are a couple other tools you can use to help you to find planets and to learn about their visibility. A great tool is called Wolfram Alpha. Now, you may have heard of this. This is a mathematical search engine, so you can do mathematical computations. Hopefully, it'll show us the correct answer. So it'll tell you all sorts of information, even with simple mathematics. But this is also a computational search engine, which means that it'll tell us about planets. So I can ask it a question using natural language, like, how far away is Saturn? And it will actually calculate this for us. And it'll actually graph it as well, so we can see that Saturn's getting closer and closer to us. I've mentioned before that Saturn will be reaching opposition soon, which means it'll be the closest in its orbit. So this is a great time to look at Saturn, because it is getting closer, which means it'll be getting brighter. So this is comparing its distance to time. We can do similar searches like Saturn's brightness, and it'll give us similar results. I believe it'll tell us its current brightness and compare it to other things like its maximum brightness and average brightness and things like that. So this is a great tool. There are apps you can download that will give you this information as well. I use this sometimes, and it'll tell you a lot of other astronomy facts as well, and you can use natural language to ask it questions like this, which is pretty cool. So that's a great tour as well. I think that is mainly what I wanted to talk about Saturn, answering that. So that was the one question we had recorded from last time. So now I'm going to head on over to the comment section. Remember, you can stream us on the Union Station Facebook page, as well as Science City and the Planetarium. And if you have not subscribed, please head over to the Arvin Gottlieb Planetarium and like and subscribe to that page, because we post all sorts of specific planetarium updates on that page, not just what you'll see on the Union Station Facebook page. So I will be going over to the Planetarium page right now, and let's see if anybody's jumping in to the comments. Looks like Ben is asking, what is the best time for stargazing with our telescope, late at night or early in the morning? And that's a great question, Ben, and it'll depend on a number of factors. The time of the year will be an important factor, because one of the challenges with Earth-based astronomy is that the atmosphere is in the way. Now, as comfortable and nice as it is to go stargazing in the summertime when it's nice and warm, unfortunately, there's a lot of heat that is radiating off of the ground even early after sunset. So what'll end up happening is that when you go stargazing in the summertime, especially if it was a really hot day, for a couple hours after sunset, there will be a lot of atmospheric distortion that'll be making things a little bit harder to spot. Looking at a planet, it might appear more wobbly and you won't be able to see as many details. So winter is a better time to go stargazing in terms of atmospheric distortion. In the summertime, I would just recommend staying out a little bit later, maybe even going stargazing in the early morning, and that'll kind of help negate some of those effects. Other than that, it really just depends on what you want to see. So, remember, during our star tours, I always show an early evening view of the skies, just because that's when most people often go stargazing. But you can go stargazing at any point in the night, and because the Earth is constantly rotating, your view of the night sky changes throughout the night as well. So if you wanted to see a certain constellation, say Orion, then you could go out in the early morning sky, or in the early evening sky rather, in the winter and spring and see Orion. Or if you wanted to see Orion in August, you could just stay out really late or wake up really early and see it in the sky as well. So that's a great thing about stargazing, is you really have a lot of options, and you can see pretty much whatever you want to see any time of year. You'll just have to plan accordingly on when you want to go out. The other factor to consider is the moon, because the moon and its brightness often does affect our views of the sky as well. When the moon is gibbous, when it's more than half full, then it is so bright it often drowns out a lot of the surrounding starlight and makes it pretty difficult to see the stars. And when the moon is waxing, then it will always be visible in the early evening. When the moon is in the process of getting brighter, it will appear before sunset and right after sunset. But when the moon is waning, after the full moon phase, and when the moon is getting darker, it'll be rising later after sunset. So a waning moon is a great time to go stargazing because the moon won't be around to disrupt your views of the sky. Now bear in mind, the moon is a really great and fun thing to look at through a telescope, so keep that in mind. You know, you definitely don't want to miss out on looking at the moon through a telescope. It's one of the most spectacular things. A little trick about the moon, though, is you don't want to go stargazing on a full moon if you want to look at the moon. Because on a full moon, the sun's light will be pointing directly at it, which means there won't be many shadows on the moon, right? Because the sun is pointing right into those craters, so there aren't a lot of shadows. But the shadows are what give the moon its detailed features and what makes it easy to see details on the moon. So if you want to look at the moon, I would recommend 1 or 2 days before or after the full moon, when the moon is still mostly illuminated but a little bit shadowed, to give you those nice poppy features so you can see all those details. We just got a question coming in from Kristen and her son Marshall, wanting to know what the oldest known star is. And that's a great question. Now, I talked about the life and birth and death of stars during a previous stream. And remember, you can check out recordings of those previous streams on our Facebook page. But one thing I talked about in stellar evolution is something called a globular star cluster. And let's see if we can find one of these globular star clusters. In fact, let me pick the one that I showed before. It was one of the Messier objects, and now I'm drawing a blank on its catalog number, but I'll pull that up real quick. So globular star clusters are groupings of tens of thousands of stars that are some of the oldest structures in our universe. So the one I want to look at is M22. So globular star clusters are leftovers from ancient proto-galaxies. So the main theory for how galaxies were formed and how the Milky Way was formed is that a bunch of globular clusters like this got clumped together by gravity over billions of years to eventually form gigantic galaxies. But these are the sort of the leftovers of those other galaxies that the Milky Way gobbled up. And these contain stars that are billions of years old. Some stars in M22, this globular cluster, are 12 billion years old. Now, bear in mind that our universe is about 13.8 billion years old. So these stars have been around since basically almost the beginning of the universe. Now, most stars' average lifespans are about 10 billion years, but this will vary depending on how massive that star is and at what stage in its life it is. But some of the oldest stars we do find in these globular clusters, and they can be almost as old as the entire universe. So Marshall, that's an awesome question. If you want to learn more about the age of old stars and globular clusters, be sure to check out the recording from that live stream a couple Wednesdays ago. I believe that was 2 weeks ago, I think. So we're going to bop on over to the Union Station Facebook page. Let's see who's tuning in over here. Connie says hi from Lenexa. That's where I'm from. I grew up in Lenexa. So thanks for joining us, Connie. And coming on down, let's see. Andra, thanks for being excited. If you have any questions, be sure to throw them in. Or if you just want to say hi, be sure to drop something in the comments. Let me ask you guys a question, though. What's your favorite planet and why? So if you want to tell me what your favorite planet is, Pluto doesn't count, I'm sorry. But what's your favorite planet? And let's talk a little bit about it, because I love hearing people talk about their favorite things in space, and we can maybe learn a little bit about planets while we're here. So Sherry says hi. How's it going, Sherry? Just checking the Science City page as well. Looks like don't have any questions over there. So let's. I got a couple other things to show you. I know it's a beautiful day, so a lot of folks are outside enjoying the weather. I talked about probes and rovers a couple weeks ago, and I just wanted to show some of my favorite imagery from some of my favorite probes. So the Cassini spacecraft was one of my favorite spacecraft. It orbited Saturn for over a decade, and you can learn more about Cassini by watching that Probes and Rovers live stream. But this is something really cool. There were some filmmakers that took tens of thousands of photographs that the Cassini probe took as it approached Saturn, and they spliced it together to form a video. So what we are seeing here is not computer generated, it is not CGI, it's not animated. These are just photographs taken by Cassini as it approached Saturn. And I'll hide myself so we can just watch this view. This is just one of my all-time favorite views. It just blows my mind that what we're seeing here is not a computer program. It's not Hollywood special effects. This is essentially video footage of a spacecraft approaching Saturn. And this clip goes on a little ways as Saturn. This is, I believe, Saturn's first approach. And it passed right by the moon Mimas. Mimas is a famous moon. It looks like the Death Star. It's got that big crater on it that kind of looks like the planet-destroying weapon of the Death Star. So we can see Cassini getting a little bit close and as it reaches an orbit. Also this amazing view as it crosses right through the plane of Saturn's rings. We can see how razor thin those rings are. The rings of Saturn on average are 60 feet thick. That's as wide as the Planetarium, actually. And even as close as this probe is, we can barely see any structure here, but these rings are made of chunks of water ice that range in size from as big as your hand to as big as your house. And Cassini continues flying over the rings of Saturn. And we're going to be passing by another moon, and this looks a lot like the moon Enceladus. Yep, that's Enceladus, the icy moon. Whoa, flying right by there. Saturn's moon Enceladus is one of the places that we think may have conditions that could support life. We don't know if there's life there right now, but below about a mile-thick sheet of ice on the moon Enceladus is an ocean of warm liquid water. So of all the places in our solar system, that is one of the top candidates for a place that could already support life. So I just really love this video of a spacecraft approaching a planet. And again, these photos aren't doctored or anything. They're just stitched together like frames from a video recording. So that is pretty spectacular. Christian is chiming in that they like Jupiter. Jupiter is pretty great as well, and I actually have a cool and similar video clip from Jupiter. So the Cassini spacecraft, unfortunately, its mission is over, and it did crash into Saturn on purpose. They wanted to destroy the probe so that it couldn't accidentally fall onto one of the moons of Saturn and potentially contaminate any life that could be there. But there is another spacecraft named Juno that recently arrived at Jupiter, and its mission is pretty similar to Cassini. It's going to be around the giant planet for hopefully over a decade as well, and its mission is similar in that it's capturing a lot of amazing footage, and this is similar footage, combining a lot of photographs of the Juno probe's approach and descent. Now Juno's interesting. It's flying very, very close to the clouds of Jupiter and capturing some very, very spectacular footage. And so you'll see, you can see every time a new image appears, and then we're just basically using geometry to stitch these images together. So that's the only thing that's being adjusted here. It's just making them all stitched together. So as we can see here, Juno makes very close approaches, and it has given us some of the clearest and most amazing views of this gas giant planet. Just these details are incredible, and every time I see a new photo from Juno, I think it looks like an oil painting. You know, it doesn't even look real, but it is, and it's incredible. And yeah, so here's Juno getting really close to the gas giant planet. Juno has revealed some amazing colors that we had not yet seen in the clouds of Jupiter. Jupiter is a lot more blue than we used to think it was. A lot of the main and most famous pictures of Jupiter you're familiar with were by the Voyager probes, which were 40 years ago. But Juno's actually revealed that Jupiter is much more colorful than that just orangey giant that we used to think of. Looks like Tatenda, I hope I'm saying that right, says hi from the plaza. Thanks for tuning in. Jerry says Saturn is their favorite. Oh, I'm glad you think so, and we took a little look at Saturn. Maybe we'll take another look at Saturn in just a minute. Tammy's husband says Magrathea is his favorite planet. I believe that's a reference to the Hitchhiker's Guide to the Galaxy. I hope I got that right. Tammy's son says Jupiter. Jupiter's pretty great. Jupiter is the biggest planet in the solar system. You could fit 1,000 Earths inside of Jupiter. Tracy, thanks for tuning in. Let's see. Let's go back over to Space Engine here. Now, this piece of software is called Space Engine, and you can purchase this to use at home. I'm not endorsing it, though. They don't pay me anything to advertise it, but it is a useful tool that simulates the entire solar system as well as the universe. You know, no big deal. But let's go back over to Saturn. Here is Saturn. I like looking at the North Pole of Saturn. This is a gigantic hexagonal storm. Scientists don't really know why this storm is hexagon-shaped, and I can actually show you an animated image of this. Let's... all right. There we go. So here is footage from Cassini that shows the storm actually moving here. So scientists don't really know why this storm has such a distinctive six-sided shape. Some scientists think that it has to do with harmonic resonance in the clouds. Some think that it may be due to subsurface convection currents. A lot of different theories about it, but yeah, that's one of those mysteries in the solar system that we still are learning about. Now, most of Saturn's rings are very bright and reflective, and we can see them through a telescope or even a pair of good binoculars. But Saturn actually has a very faint outer ring system that are a little bit more dusty. If I position Saturn right in front of the sun and brighten things up a bit, you can see that sort of external ring system farther out. Now, Saturn is not the only planet with a ring system. A lot of people don't know this, but Jupiter has a ring system as well. Jupiter's rings are all very dusty, though, so they are not definitely not visible through a telescope, and we may not even really be able to catch them in Space Engine here. Yeah, it's not going to let me brighten it up enough to see Jupiter's rings, but let's go ahead and find a photograph. Let's see. Here we go. Yeah, this let me show you guys this. So this photo I'm about to show you was captured by the Galileo spacecraft, one of the other spacecraft that explored the gas giant planet. So here is an image of Jupiter's rings from behind. So very, very thin and faint, but Jupiter does have a very faint, dusty ring system. Maybe if I line it up just right. No, it's not gonna let us see them in Space Engine, but that's all right. Let's see if we can find the other giants' rings, the ice giants. Oh yeah, so Uranus's rings are definitely visible. In fact, I can turn the brightness down and we can still just faintly see them there. So Uranus does have a very thin ring system. Yeah, now you can see it very clearly there. Let's go over to Neptune now. And Neptune has a very dark and dusty ring system, but we can see it in Space Engine here. It might be hard to see on the stream, but let's see if I can line things up for you. Alright, so you should just be able to see a very faint outline, dark outline here of Neptune's ring system. So there. If I get a little closer, now we can see it a little bit better. There we go. Yeah, so something not a lot of people know, Saturn is not the only planet in our solar system that has rings. Alright. Ryan tuning in. Ryan, thanks for those kind words. I really appreciate you tuning in, and I love doing these, and I definitely appreciate the kind words and feedback, so thank you for tuning in and watching. Appreciate you. Jumping in and checking other comment streams. The last few Wednesday deep dives were a bit longer, so this stream I won't stick around for too terribly long, just because I know everybody is wanting to get back to their Fridays. But I do appreciate everybody who has tuned in so far. One thing I like doing is surfing. There are a couple online communities that are really great for talking about astronomy. Reddit has a group all about space, and they post really fun and interesting things. Somebody recently posted a video compilation of imagery taken of Enceladus by the Cassini spacecraft, and I was checking this out earlier today, so I think it's worth checking out some of these images. We've talked a little bit about Enceladus already, that icy moon, but this is just a compilation showing us a lot of different imagery of Enceladus captured by Cassini. And some of these pictures, I've already watched this, and you can actually see the geysers of water shooting out from the poles of Enceladus. That was the first clue that we got, showing us that Enceladus did likely have that ocean of water below its surface. I'm going to adjust our lighting a little bit here. Very high tech. Let's see if Helen, my bird, wants to join us. You want to come over here, Helen? Come here. So you can see the geysers now from pretty far away from Enceladus from these images, but we'll get some even closer shots here in just a moment. While we're flying towards Enceladus, let me see if I can get my bird. What do you think of Enceladus, Helen? Green screen is making you slightly invisible. She's not interested. Sorry, guys. I guess Helen doesn't want to be on stream today. Maybe she'll join us again if she wants to. This imagery sort of reminds me of like a Twilight Zone episode, you know, flying to a sci-fi planet. There's a lot of imagery here. Ooh, there's some really awesome imagery. So here's some close-ups of Enceladus, and then we'll see the geysers. There we go. These geysers shoot up hundreds of miles above the surface. And again, Cassini did fly through those geysers and detected liquid water, and that's how we've learned about what is happening below the surface of Enceladus. Why don't we check out Enceladus in Space Engine? There it is. This is also the brightest moon in our solar system because it's basically covered in a giant sheet of ice. It reflects the most light, so sometimes we have to turn the brightness down. But Space Engine is pretty cool because it'll let us fly into these gigantic cracks on the surface of this moon. Whoa! Obviously this is slightly computer generated, but it is based on the real photography and imagery. And topology of Enceladus, and just the details aren't quite as precise since we haven't landed on this object yet. But someday we may. In fact, NASA is designing robotic submarines that we could send to moons like Enceladus, as well as Europa, one of Jupiter's moons, with similar composition. So someday we might be able to drill through that icy crust and explore the depths beneath. Oh, and I just saw we got a question from Eric, and it looks like I just answered that question, hopefully. So there are plans to send a probe to Enceladus. Let's, let me see if there are any more specifics about this mission, any updates recently. So, yeah, no updates on specific missions. There are a lot of proposed missions, though. In fact, there's one called ELF, which is stands for Enceladus Life Finder, which is a proposed astrobiology mission. It's just in the concept phase though, so engineers are designing potential probes and rovers that we could send there. Speaking of probes and rovers, I just remembered something that I wanted to mention before, and I forgot to mention on the probes live stream. The Curiosity Mars rover is a rover that has been exploring Mars since 2012. But there's another rover called Perseverance that is similar to Curiosity, kind of like Curiosity's big brother, that we're sending this year. And if you've been following the news, it's actually getting pretty close to launch. They're kind of hooking it up to its launch system now, and they've packaged it away in its landing craft. But there is a kind of a fun thing that makes Perseverance a little bit different than its cousin, because Perseverance is bringing a flying rover. So it actually has a helicopter that is attached to the probe that will be launched eventually after the rover itself lands, and I'm sure all the systems are tested out. There is a helicopter that is attached that will be attempting to fly around Mars. This will be the first aircraft that will fly on another planet, assuming the landing works okay and it isn't damaged at all. Yeah, so there we can see Perseverance getting all packed up. And yeah, so this is on NASA's website. They have a lot of great information about this probe, but that's just a cool thing. We're sending a helicopter to another planet. How crazy awesome is that? So like I said, we're going to keep this one a little bit shorter than usual. So if there are any other questions, please put those in the comments, but we will be ending in just a few minutes. Kendra's tuning in. Oh, you're welcome. I'm so glad. Kendra says, thanks so much for doing these. You look forward to watching everyone? Well, I look forward to doing these every week, so glad you're tuning in. Be sure to tell your friends to join us as well. And if you have any ideas for topics to cover in the future, let us know. We want to keep these things fresh and keep you all interested in tuning back in. We've got a bunch of different topics. The most exciting one I'm looking forward to will be on the 27th, which will be the day of the SpaceX Crew Dragon launch, where Americans are going to be sending Americans into space for the first time since 2011. But I've got a lot of other topics that we're looking at doing potentially in the future. I'd like to talk about the history of astronomy a little bit, going the hundreds, if not even thousands of years in the past. We've had people express interest on doing a show all about the outer solar system. We didn't have a ton of time to dive in deep on those topics during our solar system tour, which was about a month ago. So doing a show all about the outer solar system could be a lot of fun. Speaking of Magrathea, doing a show all about astronomy in fiction and how different fictional universes deal with astronomy and different tweaks that they make. For example, there's a simulation I can show you that will reveal how the planet in the Game of Thrones universe works, how a planet could have seasons that last years. And then one I think I'll plan on doing sooner rather than later will be a show all about the Golden Record, which was a message that humans attached to the Voyager space probes, which are now the farthest man-made objects that have ever left our solar system, or have ever left Earth. And these messages include photographs of humanity and recorded messages. So we could do a whole show showing all these different images, the story behind how the Golden Record came together. So I think that might be something I do in the near future. But again, if there are any specific topics you would like me to dive in depth to cover, then be sure to drop those in the comments. I'm doing one last pass through our comment section. Looks like I have answered all the questions for today. And I'm going to wait for one last confirmation. Oh, looks like we got one more question I may not have seen here. Let me double check, folks. All right. Looks like someone is asking if we can do a show on the Death Star. It could be fun. Yeah, so I think doing a show about astronomical worlds of fiction could be a lot of fun, and how astronomy works in the Star Wars universe would definitely be a part of that. So So perhaps we'll do that. Yeah, so I think that is going to just about wrap us up for our live stream today. As for me, I'll be cooking up my dinner. I was thinking of eating some, let's see, what is this? Dehydrated spaghetti with meat sauce, or maybe a little bit of pasta with shrimp. I'm just kidding. These are real samples of astronaut food that astronauts take to space. I will not be eating them, but they are kind of fun and gross to look at. You want to dehydrate and vacuum pack all of the food you take to space because it's very expensive to take stuff to space. Thousands of dollars for even a couple grams of food. So these are very light, nice and dehydrated. I even have, I'll make some chocolate milk later. So once again, that about does it for our live stream for today. Once again, I have been your planetarium specialist, Patrick Hess. Thanks so much for tuning in, everyone. I hope you all have a fantastic weekend. If you learned how to set up a telescope on our stream on Wednesday and you take your telescope out this weekend, then try to take a picture through your telescope or take a picture of your telescope and post it to our Facebook page. We'd love to see you setting your telescopes up, and we'll post pictures of our telescope setups as well. For the time being, though, this does conclude this week's tours. I'll see you back here, same place, same time, same pocket dimension, on Monday at 6 p.m. Catch you later, everyone. Bye-bye.